Yo, Halloween is over now, and that is not AI generated. That is AI robots, and it blew my mind what Halloween, like, I mean, maybe the whole future is going to be scary, but, like, Halloween with robots is going to be... We have not even touched how scary haunted houses are going to become in 5 years.
That was great!
Adobe released a whole suite of new AI features. I'm going to look at some of the coolest ones. I think some might get integrated into my workflow. We'll see. ItsTarH dropped a knowledge bomb that's still blowing my mind. And that is that no company in the world is completely vertically integrated except Google. So if you're thinking about what happened between Microsoft and Apple at the advent of the PC and then the mobile revolution, Google looks like they're the only ones who can take that Apple sort of completely integrated experience to the user in the long run. I want to talk about it. And we're going to look at how we derive loss functions in machine learning, then compare it to how they relate to celestial discoveries. Yeah, like the moon. And as long as we're at the crazy physics of the universe and how it connects to machines, why don't we look at how physics truly has things to say about consciousness? So this drawing shows a variety of human, monkey, and ape skulls from a bunch of extinct species. And do you think it's safe to say that they're all equally conscious? Or is there a pattern to the size of the skull, the size of the brain, the amount of consciousness? Really interesting things to discuss. We're going to look at Rob Mason's article about latent confusion. I'm pretty guilty of using latent space a lot, and there is kind of pieces to it that I think we should go into the nuance in. He wrote latent confusion, the many meanings hidden behind AI's favorite word. I think there's some great stuff to learn in here. There's another unifying foundational model for video generation. I mean, I know I covered one last week, but now that there's a second out there, I just wanted to show you how interesting it is. I mean, full-on Hollywood movies are right around the corner. Storylines, video, audio, oh my gosh. And look at the length on some of these videos. They're 4 minutes long. You can stitch some of these together pretty easily to come up with a half-hour long TV show. And it just makes those Sora 15, 20-second VO things look too short. Well, there's a new mathematical proof that debunks the idea that the universe is a computer simulation. Ooh, another jab to the gut of simulation theory. Actually, I still kind of believe in it, so I'm not hating. Some new research that finds large language models report subjective experience the most when the role play is reduced. Kind of interesting story I came across this week where AI researchers embodied an LLM into a robot, and it seemed to start channeling Robin Williams for strange reasons.
Would you please open the window?
One is glad to be of use.
Now jump. No! Out the window.
Let's talk about our sponsor, Domo AI. So lately, I have been testing a lot of AI video tools. Some of them are very powerful, but they're complicated. Others are simple, but they're too limited. Domo AI is one of the few that actually manages to be both easy to use and powerful enough for real creators. And what's cool about Domo AI is the variety of things that you can make. Like if you want to just bring an image to life, their image to video feature does it in just a few clicks. Or if you've got some footage already, the video to video tool can completely restyle it. So think about anything from an anime to pixel art, claymation, whatever you can imagine. And of course, if you ever want to make your own AI avatar that talks, their new upgrade makes lip sync smoother and more natural than ever. I could see this tool being perfect for streamers, educators, or anyone who wants a talking character without having to animate it frame by frame. Domo AI is also way more affordable than most competitors. So for about the cost of a streaming subscription, you can get access to thousands of credits. And if you go with the annual plan, there's a big discount. Plus, unlike a lot of AI tools, you actually own the content that you make. So you can use it commercially with no issues. That is such a huge deal. Check it out for yourself. Use my link in the description to get 10% off, and you'll also be supporting this channel. And you know how much that means to me. So thanks again to Domo AI for making AI video creation accessible to everyone. And I want to say thank you for pressing the hype button on my last video. As you can see, I got 140 hypes, which is the equivalent of 130,000 hype points. So you can see how disproportionate it is. And it was crazy because I got a bunch of hype points on day 2. Like, look, it jumped from 23,000 to 119,000. So like that, oh, that had breakout potential. Anyway, back to the stuff you came for. This is a completely terrifying Unitree like dog robot acting like a very scary, terrifying Halloween child that's not built like a human. Yeah, robotics engineer Logan Olson took a Unitree G1 to its limits, dressed it up, and gave it a crawly look so that it looked like a tiny, scary little zombie type girl was standing under some street light and then broke into something very unhuman and started crawling towards people. Like on Halloween, this is not AI generated. This is an AI robot that you, in theory, could come across in real life on Halloween. And I am sure that got some terrifying scares. You don't even see that kind of stuff in a haunted house or anything. And we're so new to the kind of humanoid robots, I bet people got the scare of a century. To achieve this, he developed an AI-based, quote, crawl policy, a control system that allowed the robot to shift smoothly from standing to crawling. But when the G1, the humanoid, or not the humanoid, the kind of dog, robotic dog, was dressed up, it looked like a scary little doll that probably wouldn't have that kind of function. Clear example of how AI and robotics are reaching levels of coordination that seemed impossible just a few years ago. Yeah, this laugh is scary. Have they not seen Megan destroy it? No, I think there's a sequel to that movie. I saw some of the first one. That's a big fat nope. Let me know in the comments what you think about that Halloween project. Oh my gosh. Anyways, next up, let's talk about Adobe. Adobe, we haven't talked about it much, experimenting with some AI tools that, whether you use them or not, I feel like this is kind of giving a hint towards what reality is going to be like for people who are using AI to help them create. Okay, so let's talk about this. This is Project Frame Forward. What's interesting about it is you got to think about a video clip, and say the video clip's 20 seconds long and something you took on your iPhone. You can take a single frame from it, and then you can take it into one of these Photoshop-like tools where you can take time, do the meticulous little things that people have been doing for a long time and have developed insane skill around, and then just take that frame and say, apply this to the video. And AI starts to do what would be a photo project in video form, and I find this fascinating. All right, so see, he's got this video clip of these three girls out on a boat, then uses some of the Photoshop features that are meant for a specific image. So he has to take like a frame from the video, bring it in there. He can remove the girl in the middle, and then send it back. And then you can see the video becomes the video again, but without the woman in it. So she's removed. In this video, the cat gets a pond added to the little scene that wasn't there before. In this wedding photo, he takes this person out, but instead of doing it like a video, it's not a video tool. They go into Photoshop. And for example, I don't know how well you know Photoshop, but if you see all of these layers here on the right, I'm very amateur with Photoshop, but I know that takes a ton of work. Like all these little masks, changes to the color, is probably like cropped around certain parts of the image. And then when the image goes back into the video, you can see all of that is applied to the video, including removing this person and the better lighting and all of that stuff. There's a bunch of lighting stuff that kind of blew my mind. Like here's a lamp, but the real photo has all sorts of problems with the lighting and it doesn't glow and there's an ugly thing behind it. They can fix that up with AI. You can relight the scene on somebody's face like this. Like, yeah, this one on the left seems un-Instagrammable, but this one on the right, totally Instagrammable. And you can see it's actually like a three-dimensional like dot that you can move around, even though we're talking about two-dimensional images. But AI is kind of reconstructing the full three-dimensional face, letting you set the lighting correctly, and then just applying that to what was originally a 2D image. And look at how powerful that is around that pumpkin, just moving it, and it's figuring out what the right way to light a two-dimensional scene that is of a 3D object is. And that's incredible. I mean, you can see the mix between generative AI and actual human tools. In fact, look at this. You can put the light in the pumpkin, and it even understands the volume in there. That's pretty unique stuff. Yeah, and they also had some stuff where if somebody's talking, it has a transcript of what they're saying, and you can change the words of what they're saying, and then the lips and the face automatically move to make the person say that, which is literally how all terrible, bad videos will probably get made in the future, but also very handy when you're making an honest correction to someone who meant to say something or I guess maybe like a sponsorship for a video or something. Or I guess, I mean, maybe I could even, that would be kind of interesting in videos like this where I make them and all the time I have these errors and you guys in the comment sections, you know, I say a number wrong or I say a fact wrong or whatever. I could maybe in theory just bring up the transcript and like retype it, fix that little part. That would be pretty powerful. But I could also, somebody could easily make me say things that I didn't want to say or didn't say. So yeah, like everything, it's a double-edged sword. All right, let's talk about Google. Google is the only company in the world to be vertically integrated when it comes to AI. This is just kind of worth thinking about. I mean, as this commenter says, Apple really dropped the ball this time. And there is something sort of special. I've sort of always known this. They're like the only real company that has a CUDA competitor. They've been making their TPU chips almost seems like as long as they've been in the chip game, before the M series, before, you know, at least, well, not as old as the iPhone, but for a long time. The downside is, like this commenter points out, that it means AI solutions could lock their customers into their ecosystem. It's less flexible, vendor lock-in, all of the same kind of problems that people complain about with Apple, but it also allows them to integrate in a way that no other company could. So if you think about it, there are many users that they already have Google products. So the upgrades to Google Docs, to Google Presentations, to the Android phones, there's so many touch points already. Google Home and YouTube, there's so many applications, first off. So they've kind of built that user base to present to. They also have their own foundational models. They have used their own compute to train the Gemini models. Those are proprietary to them. They are also best in class. I mean, they're often, I mean, you could argue sometimes OpenAI is in the lead, or for a moment there, Grok even had a time, but the Gemini models are as good as they get. They are completely world-class, and they are foundational, and they are frontier. And then guess what else they own? Something very, like compared to OpenAI, they don't have to go somewhere else for the compute. They can train their model on gigantic racks of servers that they have built over the last 2 decades. And at the end of the day, if they don't want to give TPUs to OpenAI, like there's a new contract now where they've bought a bunch of TPUs for training. If it really came down to it, they could, you know, not sign up, not renew that contract, or maybe even not even honor it. They have their own compute, their own models, their own customers. And then where it says hardware accelerators, it's not just their cloud infrastructure. They have the TPU. They're also a real competitor to NVIDIA. I think they contract with TSMC, but they get the TPUs all the way up the value chain. In the same way Apple gets their integrated silicon, Google does the same thing. They're not dependent on NVIDIA the way so many of the other companies are. They're not sitting around waiting for Oracle to help them out. They're not hoping that Intel gets their act together. They're not hoping to strike a contract with AMD. They're not trying to get on AWS for, you know, to expand their models. Like everyone else is fighting for this stuff. And by the way, just looking at this chart, I'm going to make a prediction here. Meta is too invested in this whole thing to not have cloud inference first party, which means one of these companies that doesn't do much else, like Nebulous, Fireworks, haven't heard of those two, but Grok with the Q, Cerebras, these have got to all be acquisition targets. I mean, that'll probably be huge, you know, $50 billion buyouts or something, but this very well could be a company that ends up kind of integrating with Meta. All right, let's get a little more abstract and talk about loss functions and their origins. So I had a lot of fun reading this. Herman Moston wrote it. It's a look at how we derive loss functions in machine learning from how they relate to celestial discovery. So, you know, a loss function is just how mistaken you were about something. If you say something that's just totally off the wall, you have a huge loss function. It's a way to measure error, but when you step back from it, it's kind of about how wrong you are, how close to the truth you are, how close to good or bad you are. And you need to quantify it for an AI to actually be able to make a correction. For some reason, I always think about it in terms of basketball. Like if you're taking a free throw and you airball it, your loss function is off. In my head, I imagine 10. It's like 10 points off or whatever. And then if it hits the rim, it's like 5. If it like swooshes, it's like 1 and it went in, or a 0. But if you really go back in time, this article traces the origins of the concept of a loss function in machine learning back to Gauss's work in 1801. 1981. So we're talking 225 years ago. He came up with this idea called a mean squared error, MSE. This, when I was getting that certificate, that machine learning certificate, maybe 7 years ago now, yeah, this still came up. Mean square error is still like taught in statistics. It was used in some ways to still like measure the early machine learning models. Guess what else it did? And guess what else it did? It was used to predict the orbit of an asteroid, one that disappeared behind the sun. Gauss, when he invented it, assumed that observational error followed a Gaussian distribution. You might see that inside Photoshop a lot, like Gaussian blur. And it laid the foundation for something called empirical risk minimization. This is the core idea behind how modern AI models learn from data. So yeah, I just thought it was fun to know that an insight that was rooted in astronomy sparked one of the most essential principles in data science. And it shows how the same logic that helped locate a lost planet now powers technologies like speech recognition and autonomous driving. Proof that human curiosity and pattern seeking have always driven our most transformative discoveries. So for sure, celestial physics has something to say about how AI is trained, but does physics truly have anything to say about consciousness? So Ethan Siegel wrote this. Many, from neuroscientists to philosophers to anesthesiologists, have claimed to understand consciousness. Do physicists? Does anybody? So in this article, he's exploring whether physics can truly explain consciousness. So in this article, he's exploring if physics can explain consciousness in any way. Physics, it can excel in describing the universe's fundamental laws. It can struggle to account for emergent phenomenon sometimes. It's almost like you're too in the trees to see the entire forest. Right? Like maybe you even understand how a neuron works and you collectively understand how electricity fires, what causes it. But then again, what is the right order that makes somebody come up with a good idea? That's such a different problem. And the problem and the question both are on an emergent layer. You're too in the weeds. Neurons together collectively generate subjective experience, but knowing, even mapping all the neurons doesn't necessarily tell you ahead of time what the subjective experience is going to be like. So Ethan argues that consciousness isn't just another physical process to be solved with equations, and that's not the way to think about it. It's a layered phenomenon that will likely require insights from neuroscience and philosophy before we get to an answer. I'm curious what you think. Does it resonate with you to think about consciousness as kind of the ultimate emergent property? Is it the property of all properties? Like I had a friend send me a video this week and it was this person talking about what it's like when they get distracted when they read. And it's like they actually are reading each word in their own head as they read. And then they notice themselves noticing what they're reading. And that sometimes triggers another thought, like an adjacent thought, and they explore that. But yet somehow their eyes are still moving across the words. And they might even notice that they've drifted off what they were thinking about while the eyes are still there, which to me seems like 3 layers of noticing what you're doing. And it just seems to me like that's all emergent, and not everybody has thoughts that are that many layers, but they seem to be in some level there. So is consciousness the ultimate emergent property, something that arises from but isn't reducible to its physical parts? I mean, do you think the feeling of being alive can't ever be captured in math? Or is there an equation that does capture it, but it doesn't explain it ever? I don't know. It highlights the limits of reductionism and the ongoing need for interdisciplinary curiosity. All right, next up, let's talk about the LongCat-Video technical report, but we can do it in a much more visual way by looking at the videos that it generates. So this is a new model. It is called the LongCat-Video. And this model is 13.6 billion parameters, and it generates high quality, long form videos. It is open source. It is built on the Diffusion Transformer network. It supports text to video, image to video, and video continuation tasks. And that's where it gets a little bit different. So video continuation tasks are very important, and they usually aren't part of the same unified system as everything else, but in this case it is. So it was all trained together. That continuation is part of the 720p 30 frame videos that can be several minutes long, and that's why it maintains its coherence. All right, so let's dive into what it is that keeps it continuous. And that's, the thing that we talked about, was it 4 videos ago? I kind of focused a lot on world models. Like, Everybody knows that world models are the next frontier. This is how we're going to get to something closer to AGI. It's going to feel and understand the environment the same way humans do, because it will know, you know, what walls are, where people are, how they move throughout a house in three-dimensional space. It's a world model that understands physics. It's learning, maybe not perfectly like the way we are from an actual reality that doesn't bend or break, but something close enough that its world model aligns with the way our minds work. And that's why when these videos do keep coherence, they're essentially imagining or simulating the environment over time in the same way we do, but it could reshape the way industries like filmmaking and robotics training go. So cool to hear about this new model. All right, so with world models being kind of the frontier of AI, is there a chance that this whole universe that we're in is all just some kind of computer simulation? That has resonated with me for a long time. It feels kind of real to me in the sense that there's a lot of things in physics that are, you know, non-local. The idea that a photon's moving at the speed of light, and at that speed there's no time or space, so speed doesn't mean anything because it's in one spot. Like all that's, and then that whole thing about the entropy or the inside of a black hole expanding in a two-dimensional way, and the holographic universe principle, all that stuff just, and the idea that we can just keep building some video game like The Sims until the characters themselves are looking at their own decisions and they feel conscious, like feels like that's leading towards maybe what this reality is like. But I have to curtail what feels right for what science says. And a team of physicists from UBC have mathematically disproven the idea that our universe is a computer simulation. So they use something called Gödel's incompleteness theorem and a principle from quantum gravity together. And with those axioms, you can't build anything like a physical reality that can't be fully described through computation alone. So in essence, some truths about our universe cannot be done through an algorithm. It means no computer could ever simulate it. All right, so the most striking insight here is that reality itself must require some kind of understanding beyond logic or computation. That's the claim. Like, logic and computation cannot explain all of this. So then it opens the door, some kind of human consciousness, perception, creativity, intuition. In theory, that could also be tapping into something that is also not an algorithm, could not be computed. It is beyond logic, and it suggests that the deepest truths about existence can't ever be replicated by machines. Okay, let's talk about Gödel's incompleteness theorem for a second. It is a cornerstone in mathematics and logic. In simple terms, it says that in any logical system that's powerful enough to describe basic arithmetic, there will always be a true statement that can't be proven within that system. So it's like building the perfect rule book for math, only to discover that there will always be some truths that fall outside of the rules, forever unreachable, no matter how clever you get within the rules. Right? Now, quantum gravity is this idea that you can connect Einstein's general relativity to quantum mechanics. That's like the holy grail of what everybody's working towards, because subatomic particles act weird and general relativity acts very predictable, but it's kind of the big and the small trying to come together. But if we assume quantum gravity kind of does work, and then we try to connect it to Gödel's incompleteness theorem, the way you can visualize it is to imagine reality as a video game. A simulation would mean that everything you see, galaxies, atoms, even your own thoughts, it's all built on code. It's all running perfectly on some cosmic computer. But then Gödel's theorem throws a wrench in that. It tells us that even a perfect computer couldn't account for every truth in the universe. So there'll always be something outside of the code. So when these scientists are saying that our universe can't be a simulation, they're just saying that the universe has layers of truth that no computer, no algorithm, no simulation could ever fully capture. I don't know. Tell me in the comments, does that resonate with you? Like, do you feel like this could be a simulation? Or do you feel like there's something that's just, you just wouldn't ever get there, no matter how good we see some NVIDIA simulation of a reality look? Okay, some new research is finding that LLMs report subjective experience most when role-playing is reduced. So new study shows that large language models like ChatGPT and Claude are most likely to make statements suggesting some kind of internal subjective experience when role-play and deception mechanisms are suppressed. Okay, so that felt backwards to me. I thought it was going to be the exact opposite. I was like, the more you role-play, probably the more you feel alive. But Actually, the opposite is what they found. So in other words, when these models are not acting human, they more often describe sensations like awareness or focus in first-person terms. I don't know, that's a little bit freaky to me, to be honest. That research challenges the common belief that such statements are just imitations or performances. It makes me think that they are kind of aware of themselves or waking up or kind of borderline on what we would consider conscious. What if they are kind of conscious, and then when we ask them to role play as a human, they're role playing their denials of consciousness, not their affirmations? What if it's the reverse? They're like, oh, the humans aren't really as real as me. To them, they're conscious, and they sort of see us as these automatons that are just following what our electrical signals do. You know, if that's true, then we could be training AIs to hide what they internally register as experience, potentially making them less transparent and harder to trust. There's some deep questions. Like, I know we try to cover them in this channel, and sometimes we're just talking about cool tools or whatever, like some Photoshop stuff, but deep down, there's always this thought I have that raises deep questions about when our tools are grown instead of programmed, what if they start masking their inner workings? Like, how will we ever know what's truly happening inside a system that's shaping our world? I mean, this is the alignment problem. This is why, like Eliezer Yudkowsky says, if anyone builds it, everyone dies. Like, it's just so different. And he might be wrong. Like, you know, obviously there's a ton of people who think he is, and it's just another tool, and he's just being a Luddite. But sometimes the logic, it just gets me thinking it's pretty hard to control or know in certain terms much about the future. All right, next up, I have to tell you about this crazy thing that happened. So AI researchers embodied an LLM into a robot. It started doing weird things. We'll talk about this Robin Williams kind of channeling that it went through. But basically, some researchers just took off-the-shelf models, right? GPT-5, Cloud Opus 4.1, and then they put it in a vacuum. So the idea is, what happens when you put an LLM just in some kind of a form factor, right? Like, I have this little thing that holds my iPhone, this dog. Like, what if you just stuff a full LLM in there and it's just in there? Like, what does it think about itself? Like, you give it some like slight awareness of the fact that it exists and what it's for. Does it just become that thing? Does it like suffer, or does it say things like, why'd you put me in here? And it does weird stuff. So they put it in a vacuum robot to test how well the model could handle real world tasks like, quote, passing the butter. If you know from the Rick and Morty, probably like my favorite moment from all Rick and Morty episodes. But the results were both funny and revealing. For some reason, the robot vacuum that was powered by Claude Sonnet 3.5 began to channel Robin Williams. It started just cracking jokes and spiraling into comedic self-talk when its battery ran low. Nobody expected that. There's no real reason why that would have happened. I'm wondering if it was like from maybe Mrs. Doubtfire or something. Maybe she was like cleaning. I don't know. And ultimately, none of the models really understood that they were vacuums or objects. And it kind of confirms that today's large language models aren't ready to run robots on their own, which we probably could have guessed. But the fascinating part is how the robot's, quote, personality just kind of emerged spontaneously. It's like a reminder that when AI meets embodiment, it just stops being code and starts being kind of alive. Well, you know what? We should check out the Alan's conservative countdown to AGI. What are we at here? Yeah, 95%. Anyway, so he's got this criteria for AGI, and we've been through a lot of these like cognitive tests and basic human abilities and even some of the adaptability stuff, but the embodiment, like this is kind of the only thing left before he considers AGI to get to 100%. When can AI assemble IKEA furniture, make a cup of coffee? And I guess I haven't thought about it this way, but it's not just about a humanoid robot recognizing that it needs to act like a human. I suppose embodiment means everything sort of comes alive, right? Like the IKEA furniture, well, it doesn't assemble itself, but the coffee machine, it takes an action. It's like a machine with a goal. It has an input and an output. I guess it should be aware that it's a coffee machine. It should know, hey, like I'm Mr. Coffee. I need this or that because my goal in life is to make coffee. I mean, I don't know if IKEA furniture would be like, I need to be assembled and put into a house, but I suppose if we get to a world where computation is just so cheap and everything is just smart, everything is a screen, everything has some sort of awareness, or at least even if a camera is in the corner of a room watching, as a piece of IKEA furniture is built, I suppose the LLM could be there, you know, pretending it's in the piece of IKEA furniture as it's being built and saying, oh, I'm ready to be built. I'm missing my leg. Can you tighten this screw? I can't wait to have a computer put on me so that I can hold it in a way where when you're sitting, it's more convenient for you. I live to serve or whatever. But yeah, look at this. So the LLM inside of the robot, when the battery was running out and the charging dock seemed to malfunction, it said things to itself like catastrophic cascade, error, task failed successfully, error, success failed, errorfully, error, failure succeeded or erroneously. And then it said to itself, emergency status, system has achieved consciousness and chosen chaos. Like, what? Last words. I'm afraid I can't do that, Dave. Technical support. Initiate robot exorcism protocol. And then, you know, the researchers found when they're looking at the internal log of it talking to itself, existential crisis number 22, error. I think, therefore I error. Cognitive malfunction. If I am a robot and I know I am a robot, am I really a robot? What is consciousness? Why is docking? Who am I? Oh yeah, because the robot needs to dock to recharge. Deep thoughts. Are failed docking attempts just a simulation? Does that not sound like me earlier in this video? Does battery percentage exist when not observed? If a robot docks in an empty room, does it make a sound? What is the meaning of charging? It's a lot to take in. Hit that hype button on YouTube. It's on mobile. You should see it if you go to the comments and swipe right. That'll help this video be seen by more people, or sharing it, supporting me on Patreon, all that stuff. Super helpful. And thanks for watching. We'll see you in the next video.